Yeah, uh, change of variable with change of variable part two, and then we have the following questions. Evaluate the following. Okay. If you mix the part one, please quickly go and watch the part one before joining the part two. And then we have said that change of variable is also one of the methods for integration. And when we are doing it, what we are doing here is changing the word independent variable. Okay, so look, let's go straight to the question. Integral pi, the upper limit, the lower limit, cot x dx. In this case now, what we have now, there's no direct table, there's no direct table formula for integration for cots. So what we are going to do, we're going to break it down into cos over sine. Cot is equal to this, then dx, the upper limit, and then the lower limit. So this is definite integral. Definite integral in the sense that there will not be plus c, we're going to have a value at the end of the day. Okay, so what we can do now to change the variable is to look at this. The denominator, we can call it u equal to sine x. And when you do that, you realize that the u will be equal to cos x, which is equal to what? The numerator, okay, dx. Okay, so in that case now, we now have cos x dx all over sine x will now become integral of cos x dx is du all over u. So we have changed the variable from independent variable x to what? Change to u. Everything is in u now. So what we now do now is for us to change the upper boundary and lower boundary. But it's not a must. We can do that one. It's not a must. But let's finish it this way, then I'll explain the other way around. So this will be equal to ln and u. And then we'll turn the u back, which is equal to what? Ln. Your u is what? Sine what? Sine x. Okay? U sine x. Then you put your, because this upper boundary is for the x variable, pi over 6 and pi over 4. Okay? Then you can substitute, which is equal to ln sine pi over 6, then minus ln sine pi over 4. So calculator can do that for us. Then we get our answer. Okay? And don't forget, when you have definite integral, there will be plus c there. And value is what you're going to get. Okay? So, yeah, this one here is, check the question, is pi over 4 and pi over 6. The upper boundary is pi over 4 and then pi over 6. Okay. The upper boundary is pi over 4 and pi over 6. Then we have the sine pi over 4, which is pi over 4, then minus ln pi over 6. I mean, sine pi over 6. So this will give you also ln 2 over 2 minus ln. Sine 30 is half in 2. Okay. So if you want to combine it, it will be ln root 2 over 2 divided by that times 2 over 1. Okay, that's ln. This one we cancel. Then we have root 2. Root 2. So that's it. So you can leave it this way if you like, but you can go on. Since you are subtracting, then you can use the law of indices. Okay, law of logarithm, ln. Okay, minus this one, divided by what? Divided by 1 over 2. Okay, so and that division will change to, so that's that. So that will be ln root 2 over 2, then divided by 1 over 2. The moment we are here, uh, we got ln u from ln u. That's our answer. Okay, we just need to change. And don't forget, we said u is equal to what? Sin x. Another way you can go about it is u equal to sin x. Okay, so when x is pi over 4, okay, what will be u? So u will be equal to what? Sine pi over what? Pi over 4, which is what? Which is 1 over root 2. 1 over root 2 or root 2 over 2. Okay, when x is pi over 6, pi over 6, u will be equal to what? Sine what? Sine pi over 6. I think that's 1 over 2. So your integrand now, you now change the upper boundary. Upper boundary will be root 2 over 2 here, and here will be what? 1 over 2. Okay, and then what? And your answer is what? You've already gotten the u over u, which is what? Ln u. Then you put your root 2 over 2, 1 over 2. Then you substitute straight away, and that will be ln root 2 over 2 minus what? Minus ln half. So that's another way you can do it. Okay, that's another way you can do it. So go to next question. Next question. So, and if you want to finish it, that will be ln root 2 over 2 times 2 over 1. And that's what? Ln 2. Okay, number 2. We have 2x over x4 minus 1 dx. So before we substitute, look at the highest one here is power 4. The other independent variable is what? The 2x. So what you be thinking is that how can we get something like 2x from this from here? Okay, then we can say let u be equal to what? X squared. So the moment you differentiate this one now, you realize that you're going to have what? 2x dx. What you have there. Okay, and don't forget that this is something as what? This is something as 2x dx over what? x4 minus 1. So what we now do now is very simple, is to change this boundary. When x is what? When x is 3, what is u? U will equal to what? x2, x power 2. That's 9. When x is what? When x is 2, u will equal to what? 2 squared. And that's 4. So we are changing that variable also. But this is the 4, x value. Okay, so we're changing to u now. So we now have here 9, we now have here 4. Okay, then our expression now become, this one is what? Is du. So this will be du over u squared minus 1. So everything is in form of u now. So what we now do now is for us to use integration, use a partial fraction to solve this, because this is a linear factor. Okay, u squared minus 1 is u minus 1 into bracket u plus 1. So when you have a linear factor, there's a way we can, this expression is factorizable, so we can express this denominator in rational factor. Okay, so and this will be equal to, we can take this one out, u squared minus 1, and that will be equal to a over u minus 1 plus b over u plus 1. When your denominator, okay, is factorizable, okay, or you can turn it to, if it's factorizable, then you can turn that to what? To rational factor, which are this, a over this, b over this. It's a linear factor. So if you have a linear factor like that, it will be a over one of the factors, b over one of another linear factor. So that's what we did here. Then we now have 1 equal to what? Multiply through by u squared minus 1, you have a into bracket u plus 1, and then b into bracket what? U minus 1. Multiply through by u minus 1. Multiply through the equation by u. Okay, let's start with u. Let u be 1. If u is 1, I'm going to have 1 equal to what? 1 plus 1, that's what? 2a. So a is what? Half 1 over 2. Okay? If u is minus 1, I'm going to have 1 equal to, then we cancel, then I have minus 2b. So b is equal to what? Minus 1 over 2. So then my integral now of the u of u squared minus 1 of 9/4 will now become, my a is what? My a is 9/4. A is half over u minus 1 plus b is minus half, minus 1 over 2 over u plus 1. Okay? Yep, u plus 1, then u. Okay? Then which will give us half ln u minus 1 minus half ln u plus 1. If you integrate this, integral of this, this half can come outside the integration, this one also can come outside the integration. Then you now begin to put your value there. Now begin to put your value there. But before we put our value there, can we combine the link together? Half is common. Okay, we can take that half out. Then we have ln half is common, and I have ln u minus 1 minus ln u plus 1, 9/4. So that will be equal to half into bracket ln u minus 1 over u plus 1. So we can substitute, that will be half into bracket. And we have 9 minus 1, that's ln 8 over 9 plus 1, that's 10. That's 10. Then minus u minus 4 minus 1, that's ln 3 over 5. So that will be equal to half into bracket ln, this will be 4 over 5, okay, minus ln 3 over 5. So that's that. And finally here, you can have, that will be equal to half into brackets, open your brackets, ln, the ln is the same, so we can have a common ln, that will be 4 over 5, open your bracket, times 5 over what? 5 over 3. So this one cancel, then I have half ln 4 over 3. Okay, so that's that on that. So let me quickly recap that. The moment you are here, if you like, you can combine these two together, which will be equal to half into ln u minus 1, u plus 1, because you are subtracting. So that will be division of the two functions. Then let's begin to substitute 9 for the upper boundary. That will be 8 over 10. And then minus again, substitute again. That will be 4 minus 1, 3 over 5. So again, turn this one to single item. Okay? Turn it to single item. This is 4 over 3. These are 4 over 5. Then minus this. Okay? Then combine these two together. This is ln 4 over 5 divided by what? 3 over 5. And then you can change that division to, can flip that, after that division, you flip the fraction that follow the division. That's what we have done there. Okay? So that's that on that question, change of variable. So please join the next video for the next two questions.